Estimating limit values from tables and graphs. As we talked about in the previous session, we were looking at graphs themselves to determine where a limit exists and didn't exist. Now, what I'm looking at here is what we call the limit and actually the value itself. Now, right here, this is the graph of x over 2, x minus 2 over x squared minus 4. Now, x cannot be 2. Why is that? Because as 2 or negative 2 approach it, I get 0 in the denominator. Negative 2 squared is 4. 4 minus 4 is 0, and that'd be negative 2. And if I had 2, 2 squared minus 4 is 0. But that doesn't mean it's not approaching it. And what we have here, where it does not, it cannot be 0. I mean, it cannot be 2 or negative 2. We have something interesting going on here. We actually have two things going on. I'll show you in a minute here. Number one, we have an asymptote right here. It's approaching negative 2. It can never be negative 2. But I have an asymptote right here. And that's why it's getting closer and closer, just like this. Also, another asymptote here. It can never be 2 for obvious reasons. But here's the other thing. Here's why there's a hole. It can never be, look at this here. If I put 2 right here, 2 by 2 is 0. Can never be at 2. But it can approach it from both sides here. I've circled these arrows right here because it is approaching both sides the same amount. And actually is, this is 1 right here, is a half. It approaches 0.25 from both sides. So we have a discontinuity right here. As an asymptote, it's also a secondary asymptote, but it's also superseded because I have an x minus 2. And if you want to remember rational functions, this is really a difference of squares. I could rewrite this, and you'll recognize this. This is x minus 2 over x minus 2 over x plus 2. And these cross off. This is one of the ones that exists. Remember, let's go from the beginning here. But when I cross these off, they cancel each other out. I'm left with 1 over x plus 2, which means x can be never be negative 2. That's why we have an asymptote. But also, where I'm asking about 2, so I cross it off, that gives me a hole right there. Now, let's look at this here. Sometimes the limit value equals the function value, and that's okay. That means there's no hole there. If what's a reasonable limit? X equals 3. Here's 3, where I got this one arrow pointing, and it goes to 1. It does exist. This is y. This is a y equals x cubed. F of x equals x cubed right here. So approaches 1, and that is perfectly reasonable. Now, this is one we talked about in our last session here. That sine wave, as x approaches right here 3, f of x, it looks like approaches also 3, and it's approaching from both ends. Now, if x at 3 equals 5, I'm talking about approaching it. It's right here, it's approaching a 3. Right here, it's approaching a 3. Get closer and closer. Now, here's another one here. Limit x, as x approaches 0, x over sine x equals 1. And remember, we have our unit circle. And remember, sine of 0 is, remember, it's cosine comma sine. And this location right here where we start out is 1 comma 0. So the sine of 0 is 0. So it can never be 0. But it can approach from both ends, and it is approaching 0. from both sides. So this is a limit. So the limit as x over sine of x uh, at 0 is equal to 1. It's approaching both ends. Now let's look at this one. This is a trigonometric function here. Limit of x approaches -4. And what's that equal to? Negative sine 0.4x when I program that in. It is approaching 1 from both ends. So it's approaching it. I'm sorry, actually, yeah, it reaches -4. It is approaching 1 right here. And there it is right there. Both sides, I got one arrow here approaching 1. And right here, it's approaching 1. It's actually -4. Now, this one does not exist, as I talked about before, looking at this here, because as x approaches 0, g of x right here, this one's approaching from the right, from the left here. As x approaches 0, f of x approaches 0. Or I say g of x right here. And then from the right here, as g of x, as x approaches 0, g of x looks like it's about negative, let's see, what is that? A -3. Let's see, that's 5. Yeah, -2 and -3. Regardless, different results. I got a hole here. I got a point that exists here, but they're not coming in exactly the same direction. And when I look at that x minus 2 over x squared minus 4, if you look at this, I'm going to put in y does exist on both sides. I could put in 1.9. And 1.9 put in for x here gives me 0.2654. I could put in 1.99 for x here and the x squared here and go through this equation. I get 0.2506. And thus we're approaching closer and closer to 0.25. In fact, I'm going, I cannot exist at 2. There's a hole there plus an asymptote. We're getting closer and closer to 0.25 as we get the f of x as the x approaches 2. Right here, same thing right here. It's undefined at 2, but it's approaching 2 from both sides. So this is a reasonable and acceptable limit. Now, here's some mistakes I want you to be aware of, people often make when doing limits. Assuming the value function is limit value. If f of x, like is x plus 2 or x equals 3, it may exist maybe something else, but we got to look at actually what it's showing there. There may be a hole there. They may approach f of x may be 2 different numbers. The value is not the same as the limit. It often is, but that doesn't mean it always is. And we're all trying to get infinitely close. It should be infinitely close on both sides, I'm showing the previous graph. Most importantly, you have to approach from both sides. Now, when I say left side, that doesn't not mean negative. It means approaching from the left side of the graph. Everything could be positive. Approach from the right means from the right side of the graph. Don't assume a left side equals a negative value. That's where the left is of the x-axis, but it can be positive on both sides. Now let's look at this. This is interesting. This is just, I'm looking at a table here. And you can see this is getting close from 4, is it closer and closer to 5 from this end. This is 6, getting closer and closer to 5 from this end. So this looks like a reasonable limit. It is approaching 5 from both ends. Let's see what the result is. 3.37, 3.5, 3.66, 3.68, 3.97, 3.94, 3.7, 3.68. Now, it is at 6, but it's approaching more like 3.6 something. So what's the reasonable limit? It'd be 3.68. Just because it equals at 6 doesn't mean it's approaching at 6. And, I would say you could even do 3.68. You could have done 3.69 I'm giving you the best choices here. It's not 4, it's not 6.37, it's not 5. They're both approaching 3. It looks like it's from both sides, 3.68. So somewhere in that. Again, don't confuse the limit value with the function value. Where are we approaching? Not where we're at with that x. And remember, also, thing it's always got to be a whole integer. It can be a fraction as well. It can be a decimal point. That's okay. Now, as x approaches 7, let's take a look at this here. Here's 6, 6.9, 6.99. There's my 7. And this is going to 8, 7.01, 7.0001. And this looks like it's 3. It's g of x 3.4, 1.9, 1.92, 4.6, 1.1, 1.92. About 1.92 both sides. It may be undefined at this point. But even though it's approaching 7, it may be undefined. But what are we approaching? We are approaching 7. It may not be able to be 7, but it's approaching 7. That's what we're looking for here. One more here. We've got a graph here, and I've graphed this. And it looks like it is just a series of dots. Kind of looks like a regression equation. But I've got, on my x, I got 2 through 8 right here. It looks like it's 3.7, 4.3, 4.9, 4.8, 5.6. I don't have 5 here. But let's see where it's approaching. Here's 5 right here. Now it shows actually, I'm sorry, I did it as a 5. As x equals 5, now it shows here, and this is interesting, 3.7, it's growing until it gets to this point, this dot right here. But for a limit, it's approaching about 5 point, looks like about 5.3. So even though it actually exists at 4.8, it's approaching about 5.3 from both sides. And that is the point of a limit where it's approaching. Now, actually, where it is at that x, f of x equals the x, but where it's approaching from both sides.